A Short History of Vacuum Tubes. In 1883, following his invention of the light bulb, Edison discovered current flow inside an evacuated light bulb. The Edison effect is current flow from the negatively charged lamp filament to a positively charged separate plate located inside the light bulb. At this period, there was not yet an awareness that electrons could flow through a vacuum between two polarized electrodes. In fact, electrons weren't identified until 1897. In 1904, Sir John Fleming developed a vacuum diode based on the Edison effect that could serve as a detector in a radio receiver. This was the beginning of the vacuum tube dynasty, a lineage that used a negatively charged filament or heater to liberate electrons from a cathode surface, plus other internal control electrodes interposed on the path to a positively charged collector or anode surface. In 1907, Lee de Forest interposed an electrode between the cathode and anode of the Fleming valve. With the application of almost zero electrical energy, this third element, called the grid, could control the large flow of electrons from the cathode to the anode. The grid electrode of the Audion, as this new device was named, functioned much as a handle on a water valve, controlling a huge flow with very little effort. However, the first Audions were highly non-uniform. As late as 1915, de Forest himself stated that he could not predict whether the anode current would go up or go down when a signal was impressed. In 1912, Western Electric Company used a modified de Forest Audion to build a telephone amplifier. It led the way to coast-to-coast communication in 1915. 1914 to 1918 was the World War I period. The demands of the military initiated a tremendous push to build dependable tubes. Western Electric produced more than 500,000 tubes named the VT-1 and VT-2 for the U.S. Army. General Electric copied the Western Electric design. They changed the filament voltage and the base and renamed the tube VT-11. More than 200,000 were delivered to the U.S. Army and Navy. Western Electric made the first 50-watt power tube. RCA built the same tube, calling it the UV203. In 1919, the equipotential cathode was invented, permitting the use of AC voltage on the filament heater of a tube without introducing any hum into the process signal. This invention would have eliminated the need for battery operation of the filaments. However, manufacturing problems and cost prevented its adoption. In 1920, two tubes dominated the market: the UV200 soft vacuum tube for detector service and a hard vacuum UV201 for amplifiers. The tungsten filament, very power hungry and sensitive to voltage changes, which ruled out the use of AC voltages, had to be operated from Husky batteries. In 1922, the invention of the copper-to-glass seal and the water cooling of the vacuum tube permitted huge increases in power handling. Vacuum tube-equipped transmitters jumped up in power from a 500-watt maximum to 50,000 watts. This fact, coupled with the use of frequency-stable tube oscillators, sounded taps for the only other competitive transmitter technique, the Polson CW arc device. In 1923, Westinghouse develops and RC manufactures the WD-11. The UV199 peanut tubes followed, offering an even more efficient filament, bringing about a great saving of battery power. This same style filament was installed in the 201 tube, which was renamed the 201A. It made use of the more efficient filament, or A battery power. In 1927, the equipotential cathode was finally put into service in the new type 226 and 227 tubes. This type of cathode, immune to noise and hum, was heated directly from a step-down transformer operating from the AC line. The Type 280 was the first of the high-efficiency tubes to be used as a rectifier for the high-voltage AC from an isolating transformer. This combination of tubes resulted in the first hum-free AC operation, no batteries. In 1929, the new Type 224 tetrode tube was the first advance in function since de Forest's Audion, built on the findings of the Fleming diode valve. It introduced the triode vacuum tube. The extra element, called a screen grid, isolated the input circuit from the output circuit, resulting in much more stable operation and delivering much more amplification for each stage. Post-1929, from this point on, there were very few, if any, significant basic changes to tubes. However, improvements were made in size, expense, and energy efficiency. In 1946, the ENIAC computer was completed. It was one of the first computers and used 18,000 vacuum tubes. The 1950s. This was the decade of the transistor, which was rapidly proving superior in all ways to the vacuum. In 1958, the last significant receiving tube development was the RCA NuVistor. Smaller than the end joint of one's little finger, it was a technological achievement, but once again the tube was soon to be surpassed by the transistor.